In this example, we will consider the series 16x to the k from k equal 1 to infinity. We'll ask to find its interval and radius of convergence. So remember, what we're really looking at is we're asking what x values can I plug in to make this series converge. Different values of x will work. Some may make it converge, some may make it diverge. But for an obvious first example, if x is equal to 1, then that's 16 to the k, which is going to be 16 plus 16 squared plus 16 cubed. That's obviously going to go to infinity. But if I plug 0 in, then these are all to 0, and 0 plus 0 plus 0 converges. Some values of x make it converge, some values of x make it diverge. Our goal is to figure out which ones make it converge and which ones make it diverge. And so for almost all of these, what we're going to do is we're going to use the ratio test. And remember, in the ratio test, what we're looking at is the limit as k goes to infinity of absolute value of ak plus 1 over ak. That's what we're looking at. If this limit is less than 1, it converges. If the limit is bigger than 1, it diverges. And so this is our general strategy for most of these questions, where you have a series that has an x in it. Think about x as a variable. Some values of x make it converge, some make it diverge. In order to determine what values of x will work, we will use this ratio test. Now, many times we were able to drop the absolute values because the terms were positive, but x might be negative. So we're going to have to be much more careful about doing that, and most of the time we may not be able to drop the absolute value. ak plus 1, remember what that means. That means plug k plus 1 in for k. So that's 16x to the k plus 1. ak is just the actual series that we see, 16x raised to the k. This really is still absolute value. So there's k plus 1 of this on the top and k of the same thing on the bottom. So it's just like x to the k plus 1 over x to the k. Everything will cancel off except for a single version of the 16x. So this is limit as k goes to infinity of the absolute value of 16x. All of them have gone away. I have k plus 1 of them up here, k of them down here. They're all gone except for one copy. Again, I can't get rid of the absolute value because x may be negative. But as k goes to infinity, there's no k's left. There's no k involved in this at all. So as k goes to infinity, this limit is just the absolute value of 16x. I can do a little bit of algebra and say that that's 16 absolute value of x. Here's where it gets a little tricky until we've done enough of these to get used to what's happening. Remember, we're taking this limit and we're saying, when is that limit less than 1? If the limit is less than 1, then the series converges. So our next step is to say, when is the absolute value, or 16 absolute value of x, less than 1? That's the same thing as saying so that's what we're looking at. We're looking at absolute value of 16x, or 16 absolute value of x less than 1. That's the same thing as saying absolute value of x is less than 1 over 16. Now this is going to become familiar after we do a bunch of these, but if the absolute value of x is smaller than a number, that means that x is smaller than that number, or else the negative version is bigger. Right? If I said absolute value of x is less than 10, then anything between negative 10 and 10 will work, because negative 9, put that in absolute value, that works. Negative 9.5 works, but negative 11 does not. So that's really what we're looking at in almost all of these situations. Negative 1/16 less than x less than 1/16. So the language here, if I were to graph this, and this is negative 1/16, and this is positive 1/16, we know that it converges for all of those values. If we think about 0 as the center, then it moves 1/16 in either direction. And so our word here is the radius of convergence. You want to think about it as starting at 0 and drawing a big circle of radius 16, 1/16. And if you do that, then you have the shaded region that's right here. It really is a circle when we look in higher dimensions. In a single one dimension here, if I have just a function of just one variable, it's a segment instead of a circle or a sphere. But in higher dimensions, it really is a sphere, which is why we use the word radius here. Now that's fine, but if x is actually equal to 1/16, actually equal to 1/16, not less than or equal to or less than, these are less than symbols, because if x is equal to 1/16, then we end up getting 1 here. And remember that the ratio test doesn't give us any information if the limit is 1. So at these endpoints here correspond to a ratio test giving a final limit of 1, which is actually no information. So we have to check those endpoints separately. Okay, so right now we've got radius of convergence of 1/16, but I would like to check each of those endpoints separately to say, do they converge? Does this series converge? So we have to check the endpoints. If x is equal to positive 1/16, we're just going to plug x right in and see what happens. I get 1 to infinity, 16 times 1/16 to the k. I just plug 1/16 in for x. That is sum from 1 to infinity of 1 to the k. Well, that's like 1 plus 1 plus 1 plus 1, and that goes to infinity. So it diverges. So at 1/16 it diverges. If it's possible, sometimes we'll do this and wind up with converge. And if that's the case, we would have turned that into less than or equal to actually say at 1/16 it converges. In this one we don't, it still diverges. At negative 1/16, I get 1 to infinity, 16 times negative 1/16 to the k. Well, that's negative 1 to the k. Negative 1 to the k is negative 1 plus 1 minus 1 plus 1 minus 1 plus 1. Remember that that is a series which also diverges because it does not shrink down and into a single final value. It's always plus 1 minus 1 plus 1 minus 1. If it were to converge, they would have to shrink down into a single value, and it does not. So this one diverges as well. So we do not add an equal to symbol on either of those sides. And we say that the interval of convergence is the interval negative 1/16 to positive 1/16, rounded edges on each because it does not include either endpoint.